Hello friends, in this video we are going to study about the exception flags present in the 8087 coprocessor. We will study that how many exception flags are present in 8087 and then we will see the description of all these exception flags. So let us start with our topic. We know that the 8087 coprocessor, it performs the high speed calculations, like all the numeric calculations, arithmetic and logical and trigonometric calculations, they are performed at very high speed by the 8087 coprocessor. So while performing these numeric calculations, if any error is occurring, then that error is called as an exception in 8087. So what is an exception? It is nothing but an error which is occurring at the time of numeric calculations. So what the 8087 coprocessor do whenever any error or an exception occurs? Okay, so error can occur during any numerical operation. So what this 8087 does, for that error there is a corresponding bit present in the status register. In the status register, it is a 16-bit register. Out of in these 16 bits, there are some bits which are assigned for the exceptions, that is for the errors. So if any of the error is occurring, then that corresponding bit will be set by the 8087. Now, after setting that bit in the status register, the 8087 is now going to check that whether that error is masked or unmasked. Okay. So after setting that corresponding bit, it is going to check that exception is masked or unmasked, and this masking and unmasking is specified by the bits in the control register. In control register also there are some specific bits for these exception flags which are for the masking and unmasking. So if the exception is masked, okay, it means that the error will be ignored. Error is not going to occur. Okay, and unmasking means that the exception flag is not masked, then error is going to occur. Okay, now this error, it acts like an interrupt for the processor. Interrupt means that we are stopping the execution, the current execution of 8087, and we are interrupting it, we are disturbing it. Okay, so this exceptions, they are going to act as an interrupt. So when the 8087 it has discovered that an error has occurred, it has seen that that error is not masked, it is in unmasked condition, so it is going to generate an interrupt signal and it is going to interrupt the microprocessor via the 8259, which is the programmable interrupt controller. Okay, so this controller is going to interrupt the microprocessor can be 8086 or it can be 8088, because 8087 is a coprocessor for these two microprocessor families. Okay, so these microprocessors can be interrupted by the 8087 whenever it has encountered any unmasked error. Okay, so this is how the 8087 coprocessor it deals with the exceptions. Okay, now there are various types of exceptions present. Let's see that how many exceptions are there in the 8087. First is the precision exception. Then underflow, overflow, zero divide, denormalized operand, and invalid operation. So there are six exception or six errors exception flags present in the 8087: precision, underflow, overflow, zero divide, denormalized operand, and invalid operation. Let us study them in detail. So first exception is the precision exception. So precision exception occurs whenever result of any numerical calculation is cannot be represented in a given format. Means if we are having a set format to store the result and the result of that numerical calculation cannot be expressed in that format, so at that time the precision error is going to occur. So an example of this can be the mantissa of the result. It is too large to be stored. So in that case, the result is rounded off and then that result will be stored. Okay. So if mantissa is too large, to be stored, then result is rounded off and then it is going to be stored in the memory. Okay, so in any case, whenever the result cannot be stored or it cannot be represented in the given format, then this error is going to occur. And how the 8087 will get to know? The corresponding bit will be set to 1. After that, the second exception is the underflow exception. This exception is also known as the D-normal number. Underflow means that the number which we want to store in the memory or in the register, that number is very small. Okay, so we can say that it is a D-normal number or abnormal number. So it is a D-normal. So this type of exception or error is going to occur if the result is a non-zero number. Result is non-zero, but that number is too small or so small that it cannot be specified in the given format. Precision exception was that the number cannot be represented in that format. So we do rounding of that number. But here the number is too small that it cannot be specified in the given format. The example is that the biased exponent is too small. So after biasing, the number has become a negative number. Exponent has become negative. Now instead of storing a negative exponent, the 8087 what it does, so when the exponent is very small, after biasing it has become negative. So instead of storing the negative exponent, what the 8087 does, it stores the exponent as all zeros, means exponent has become zero and the underflow exception is being generated. So processor will get to know that the number is very small to be specified in that format. So this was the second exception, that is underflow exception. After that, the third exception is the overflow exception. Just like underflow is known as the denormal number, overflow means that the number is too large. Okay, so it is not a number, also known as not a number, that is NaN. Now this error, it occurs if the result is too large to be specified in the given format. So in the underflow, the biased exponent was very small. Here the biased exponent is too large. So what the 8087 will do, it will make that biased exponent as all 1 and then it will generate the overflow exception. In underflow, the exponent was made all 0, but in overflow, it is made all 1. Okay. So this is how the 8087 processor is going to know that it is an overflow condition and this is the underflow condition. Now in the underflow condition, if the mantissa and the exponent contents are all 0 and mantissa components are all 0, then it will be considered as a 0 number. Whereas in the overflow exception, if all the means that the exponent is all 1 and mantissa is all 0, then it represents an infinity. Okay, so this is a note. Exponent all zeros, mantissa all zeros, so that represents a 0. If exponent all ones and mantissa all zeros, then it represents infinity. Now next exception is the zero divide exception. This exception or error is going to occur whenever we try to divide a non-zero number by 0. Okay, like for example, if we want to divide 37 by 0, then 37 is a non-zero number and we are trying to divide it by a 0. So it's a zero divide error. So whenever we are trying to do the operation like a non-zero number divided by 0, then that is going to generate a zero divide exception or error. Okay. Next exception is denormalized operand exception. This type of exception occurs whenever one of the operand is a denormalized number. Okay, means it is not a normalized number. There will be two operands in any of the numeric calculation. So out of those two, if any one of the operand is denormalized or not a normalized number, then this type of error or exception is going to occur. Next and the last exception is the invalid operation exception. This type of exception or error occurs whenever there is an attempt to do an invalid operation. Okay, examples of invalid operations are like if we want to store a number in a register whose capacity is very less, like if the capacity of the register is to store only an 8-bit data, and if we want to try to store 16-bit data in that register, then it will be an invalid operation. If we want to find out the square root of a negative number, then it is also an invalid operation. Suppose that the stack is empty and if we want to retrieve the data from the stack, then stack is empty, how can we retrieve the data? So that is also an invalid operation. So it occurs when any invalid operation is done. Like for example, 0 is divided by 0. Another is the square root of a negative number. Then stack, underflow. So these are some of the examples of the invalid operation. So out of them, if any of the operation is tried to attempt, then this invalid operation error is going to occur. So these are the 6 exceptions occurring in the 8087 coprocessor. We studied them in detail. First was the precision, then underflow, overflow, zero divide, denormalized operand, and the invalid operation. For all these exceptions, there is a corresponding bit in the status register which tells that which of the exception has occurred in the processor. Okay, and after that generation of the exception, the bits is in the control register. They are checked that whether the error is masked or unmasked, because these exceptions they work as an interrupt for the coprocessor. Whenever any error has occurred and it is unmasked, then the 8087 is going to interrupt the microprocessor by using the 8259 programmable interrupt controller. So in this video, we studied the 8087 exceptions or exception flags or errors. So I hope that this video is now clear to you. Thank you.